This is Worksheet 17, Problem 1, and these two problems come from your next homework, and they should help you do the problem that you need to turn in. These problems use a counter, and this is what we're using as our counter, and it has the following characteristics. If enable and load are both 0, enable and load are both 0, then the action is to hold, or the next value of your Q's, Q0, Q1, Q2, and Q3 are the same as their previous values. If enable is 1, but load is 0, then it functions as a counter. And so the next values for the Q's will be the next higher binary number using the digits Q0, Q1, Q2, and Q3. And we'll see how that works in a minute. If load is 1, then at the edge of the next clock cycle, the values of Q become the values that are loaded into the inputs D0, D1, D2, and D3. So here in problem A, we can see that the load values are 0, 0, 0, 0. So when load becomes enabled, Q0, Q1, Q2, and Q3 become 0, 0, 0, 0. So it would start the count back over from 0. So we don't actually know what the values of Q are when we start, but let's assume that our values are 0, 0, 0, 0, and we'll see later what we'd do if they were not. But before we can do this, you need to be able to count in binary using 4-bit number. And so let's just make sure that you can do that. So we have 0, 0, 0, 0, then 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, sorry. One one zero one, 1 1 1 0, and 1 1 1 1, and those correspond to the decimal numbers 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Now, one property that you might notice that'll be important later on is notice so that Q0 alternates 0 1 0 1 0 1. Now, when Q1 is 0, then Q0 does its alternating 0 1. Then Q1 becomes 1, and while Q1 is 1, Q0 does its alternating 0 1. And then when Q1 is 0 again, Q0 does its alternating 0 1. And so forth. Now, let's see, when Q2 is 0, there's 4 values, and while Q2 is 0, Q1 does its alternating 0, 0, 1, 1, and within each one of those, Q0 does its alternating 0, 1, 0, 1. And then when Q2 becomes 1, while it's 1, Q1 and Q0 alternate using their patterns. And then when Q3 is 0, you see that these first 3 bits alternate, and then when Q3 becomes 1, the last 3 bits alternate. And so you have a continuing recycling of the alternating pattern. But for right now, let's just look and see what happens on this counter. So we're going to say we start with 0, 0, 0, 0. And then it's going to act as a counter, and nothing's going to happen until this load is enabled. So let's see when the load becomes enabled. This is Q3, Q2, Q1, Q0. So load is not enabled, so the next clock cycle will be 0, 0, 0, 1. load is still not enabled because Q3 is still 0, so Q3 is the value going to load. So then we go to the next value, 0, 0, 1, 0, and so forth, and we keep doing that until we get to 0, 1, 1, 1, and then on the next value we have 1, 0, 0, 0. Well, now Q3 is 1. So Q3 is 1, and so now load is 1. So on the next clock cycle, the Q0, Q1, Q2, and Q3 will be 0, 0, 0, 0. And now that we're back to 0, 0, 0, 0, Q3 is now 0, so load is no longer enabled, so it'll go back and count 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and so forth, until once again it gets to 1, 0, 0, 0, and then Q3 is 1, load will be enabled, and it'll go back to 0, 0, 0, 0. So this is a counter. If we look at the decimal numbers, it counts 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 0, 1, 2, so forth until you get to 8, and then 0, and then so forth. So this is what's called a modulo 9 counter. It has 9 digits, so there's 9 of those, starting with 0, and it will repeat when it gets to any value that has Q3 equal to 1. So we saw what happened if we started with 0, 0, 0, 0. Let's say we didn't start with 0, 0, 0, 0, but we started with, let's see, whatever this value is, 0, 0, 1, 0, what's that? That's 2. So let's say we start with 2, 0, 0, 1, 0, so we start with 2. Q3, which is load, is still 0, so it will act as a counter, and it'll go to the next value, 0, 0, 1, 1, which is 3. And then there's no reason for it to do anything different but to count, and so it's going to continue counting until it gets to 1, 0, 0, 0, where Q3 and the load are 1, and then it'll start over again. And this time when it starts over, it'll start over at 1. So this counter, when we started at 0, it went 2, 3, 4, 5, 6, when we start at 2, it goes 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 8, 0, and so forth. Okay, well, what happens if we start at some other value? Let's say we start at some value that's not in this sequence. If we start with the value that's in this sequence that goes, within this sequence right here, we start with any value in this sequence, it will go until it gets to 8, and then it'll go back to 0. So if we start at 5, it'll go to 8, and it starts to 0. What happens if we start with any value that's down here? Let's say we start with, for instance, 12, 1, 1, 0, 0. Then on our very first value, Q3 is 1. Q3 is 1, so it goes to load, and it'll load 0, 0, 0, 0, and then it'll go 0, 0, 0, 1, and so forth until you get to 8, and then after 8, it'll go back to 0, and then 1. So if we started with 12, it would go 12, and then 0, 1, so forth to 8, and then 0, 1, and then so forth to 8. And the same thing is going to happen with any of these values from 9 to 15, because from 9 to 15 they all have Q3 equal to 1.